This video will demonstrate how to implement the array index operator for the Deque using the array of arrays implementation. Hello, I'm James Helfrich. The array of array implementation of the Deque is one of the most complicated implementations in the standard template library. We have an array of pointers, each pointer to a fixed number of elements in another array. But the question is, how do you find a given cell or a given element in the Deque based only on the index? This video will demonstrate how to do that. There are 4 different index schemes for an array of array implementation of the Deque. There's ID, IC, IB, and IA. ID is the index relative to the Deque. ID equals 0 is the front element. This is the index that the user or the client works with. IC is the index of a cell within a given block. In the example below, there are 3 cells per block, and so my indices will be 0, 1, and 2. IB is my block index. In the example below, there are 5 blocks, blocks 0, 1, 2, 3, and 4. So IB goes from 0 to 4. And finally, there is the IA, and this is the index relative to the internal array if each block were laid on end. And these indices go through 0 through 14. You can see the pseudocode to convert a Deque index into an array index, as well as the pseudocode to turn an array index into a block index and a cell index. I could find the cell index by saying IA mod number of cells. To see how this works, take a look at this example. I have a Deque of integers, and there are 7 of them. So initially, when I create the Deque, I'm going to have 4 cells, because this array implementation has a block size of 4, and there are 2 blocks. Notice how IA head is 0. In other words, IA and ID are both aligned because we're not in a wrapping situation at this moment in time. Now, when I say Deque of index 5, what does that mean? Well, first of all, my Deque index, ID equals 5. My array index is 5 Deque index plus IA head, which is currently 0, so that's 5, mod number of cells, which is 4, times number of blocks, which is 2. So that's 5 mod 8, which is still 5. Now that I have my array index, I can find my block index, and that's 5 integer division 4, which is 1, and cell index is 5 mod 4, which is also 1. Therefore, I'm going to look at block 1, cell 1, which is array index 5, and that's currently has the value 26, and I'm going to replace 26 with my 90. Now, when I say push front 19, that's going to change many things. First of all, notice I don't have space at the front of my Deque. Therefore, I need to reallocate. I need to create a new block, but all the blocks are currently used. So now I have to have a new array of blocks. And this is going to change many things. Notice how my number of cells remains at 4, but now I go from 2 blocks to 4 blocks. Now, notice also the 2 blocks do not move. I'm going to go back one. The blocks do not move. It just, I reallocate my array of pointers. And that's an important detail about the array of array implementation is we don't actually move elements around. We just move pointers around. Okay, after I have reallocated my Deque, now I have room for a new block. And this block is going to go in front of the front element. And the front element is 21. And what goes in front of that? I have to wrap it all the way around and put it in the block 3. And so now my IA head is now cell 15. So it goes 15, 0, 1, 2, 3, 4, 5, 6. And those are the array indices of my Deque. Now, when I say Deque of index 5, well, what is that? Well, Deque index is 5. 5 plus 15, because IA head is now 15, that gives me 20. 20 mod num cell, which is 4, num block, which is 4, which is 16. 20 mod 16 is 4. So that's my array index is 4. Now, my block index is going to be my array index, which is 4, divided by number of cell, which is also 4. And 4 divided by 4, integer division is 1. And 4 mod 4 is 0. Therefore, I expect to find this element in block 1, index 0. And now I replace that with 80. Okay, now I'm going to add 4 elements to the front, and this will fill block 3. So notice how I don't have to allocate a new block or anything, but IA head is now going to go from 15 to 12, and that is now the front of my Deque. Now, when I say Deque of index 5, Well, I need to figure out what my array index is. So I'm going to take 5 plus IA head, which is 12, which then it gives me 17. And then mod 16, which is 1. So now my array index is 1. So my block is going to be 0, and my cell index would be 1. Therefore, block 0, cell 1, which currently has the value of 22, now has the value of 70. Now I'm going to push 2 elements in the front of my deck. Notice how block 3 is full, so now I have to allocate a new block in front of that, which would be block 2. IA head goes from 12 to 10. And we expect that. If we push front, we expect my IA head to decrement. Now, if I say dec of index 5, my ID will be 5. My array index would be 5 plus 10, which is IA head, which is 15. 15 mod 16 is still 15, so that's my array index. So this is going to be slot 15, which currently has the value of 19 in it. Now my block index would be 15 mod 4, which is 3, and sure enough, that is in block 3. And my cell index would be 15 mod 4, which is also 3. So this would be cell 3 in block 3, which currently has a value of 19, and I'm going to replace that with 60. You can learn more about how this works in the Deque chapter of the C++ data structures textbook.